Hi, before I begin this video about the Sun Grid Tie 2000 watt 240 volt split phase inverter, I wanted to thank Andy, who has a YouTube channel called Off Grid Garage, who gave me a lot of ideas about doing my project correctly. And I want to show you some of the things that I learned from him, which is right behind me here. Here's one of the ideas that I got from Andy, is buying this charger right here, which I'm very pleased with it. It's a 5-volt charger, 40 amps. And so what I did is I top balanced each of my 16S4P cells, which are right here, the 60 by 280 cylindrical cells. These are rated from the factory at 50 amps. So 4 of them in parallel would be 220 amps. But I did a test with this. This is, unfortunately, was only 10 amps, but it produced 240 amp hour going down to 2.5 volts. Now they were fully charged at 3.65, and I had this thing set for 3.65, and when it got down to 2 amps, it shut off. Started off at 40, when we got down to 2 amps at 3.65. So all my 16 series were done one at a time, took 2 to 3 days. And these are ideas that I got from Andy at the Off-Grid Garage, which I'm grateful for. Thank you, Andy. And let's go on with the video. To follow the source backwards, this is my sub panel in my garage. And the power goes from there to this meter, to my 240 volt General Electric timer, and this timer is set between 5:30 in the evening until 8:30 in the morning. It's a 240 volt timer, and that follows along here. Set up a mousetrap to that fuse box right here, and this is the main AC fuse box that goes following that conduit to my inverter, which I'll show you in just a second. We're going to start off with the 2000 watt Sun Inverter. This is a G2. At the top, it has a limiter. And since I have this in my garage, it goes down to one of my power lines going out. Since I have it in my garage and I rarely do anything at night charging, because I charge my cars during the day, which uses about 6,700 watts of 240 volts. This runs only at night. I haven't run for this demonstration to show you. Right now it's putting out 448 watts. You can hear the charger in the background. I'll tell you about that in a second. A very important thing to know about this particular inverter is that this is a split phase for the United States, and it has a normal computer plug, which is normally 120 volts. And usually there's a neutral and a positive on one side, and then there's a ground on the back side. Well, on this thing, to only get this to work, you are going to have line 1, line 2, and neutral for this 3-prong plug. Goes against everything you think about, but that's the only way this thing will work. It's a 240 volt split phase grid tie inverter. It's not a hybrid inverter. This will only work if you have the grid hooked up. The grid goes off, this goes off. So right now we're putting out 450 watts, and we're at 55.1 volts in our battery pack. Let's go in here to settings. Click that, and you'll notice that I have this checked off right here, and that's only because I want the LCD to show up during this presentation. Other than that, I don't have it checked. It only stays on for a few seconds. And this is the limiter right here. I do not have that checked because I don't use enough wattage, because it would just measure the wattage I need and produce that here. And as I say, I don't charge my cars at night. So I have it set on the manual one, which is that check mark right there, and I have it set at 9 amps. And that is putting out about 450 watts. And I have it set right here. You'll notice that the cutoff voltage is 49.5 and the reboot voltage is 50.5. And so once you get this set, you click this, or I should say you click this, and you're going to want to check the yes, highlight the yes and push that, and it'll save all your settings. Now this goes back to your output. Actually, I've had one of these before, the 1000 watt Sun grid tie inverter. Oh, I must have unchecked that because it went off. Let's go back and do that again. Click and clicked. There we go. Then it's going to ask yes. And there we go. And click that again and you go back. So, as I say, I don't use this during the day because my solar panels on my dike puts out about 21,000 watts. I most certainly am not using anywhere near that power. Probably 2/3 of my power that I generate goes back into the grid. Now this is all going back in the grid. I don't want to deplete my batteries, but for this demonstration I'm going to show you. Then we have it hooked up here at the top, your positive, negative. This is number 4 welding cable. And it comes down to this right here. Very important. This is a 100 amp breaker. And it's good for up to 125 volts. I had to make this because it's designed to go in a special panel, and I don't have that. So it comes out here to this wire and comes right over here to right there, that one with the white tape on it. The red tape is for my charger, and that's just extra cabling I have. Extra cabling I have for the... just extra cabling I have, and goes right over here to my positive and my negative. And this is specifically made for lithium iron phosphate to charge it up, your cells up to 3.65. I have it on a timer because I don't want to stress out my batteries. So it's on a timer. It comes on at 9 in the morning when the sun's out, and goes off about 1:30 in the afternoon, just to keep it in the range. And that's why I'm only taking 9 amps out of here, because I have it on for about 10 hours. So let's just go over to this. Oh, well, let's show you this part. I put 2 wires here. One is for this, and this is a balancer that is designed for a 16S system. Do I like it? No, I don't, because it throws one of the cells over 3.65. I was shocked, and it gets quite warm. But what I do like, and with the other wire, of course, is for this Dali 150 amp 16S. This is for lithium iron phosphate BMS. I wouldn't have a system now that I've done it, because initially when I first started out listening to J. Hugh Garcia about building power walls and that stuff, he didn't use BMSs. I would not ever use make a power wall without a BMS. And what's really important about this Dali is this Bluetooth. And why it's so important is that it lets you know which each of these are cylindrical cells. They're 60 by 800 millimeter. Pretty sure that's what it is. And they're 55 amp each. That puts about these 4P into 220 amps. So since they're all in series, that's all I have. I have 57 volts at 220 amps. So as you can see that I made all my bus bars from scrap aluminum I had and scrap copper. This is 1/8. Now this is 1/4 inch. This pot copper, and this is on the negative. The aluminum is on the positive. And the reason I put those on there because these are aluminum. These are steel. These nuts right here are steel, and these are aluminum. So I want to keep the aluminum on there. And these little little thin aluminum, not aluminum, copper. I made those also, and I also made these right here just so I could solder on my top balancer and my BMS leads. So, getting back to the Dally, I'm very impressed with this Dally BMS, and I will show you the screen on that in just a second. Now we're looking at my iPhone here, and what the app is for this Bluetooth is called Smart BMS. Let's click on it, and it's connecting right there, and that is this one. You see the little Chinese stuff. I have not set the correct state of charge. It's got more than 1.7. But what I like about it is that you can adjust the BMS yourself, not from factory settings, but from your own settings. Okay, right now you can see the blue right there. It varies because that's the low and the high. These are balancing themselves. They're really in tight balance. And you can see right there it's 8 degrees centigrade in here right now. And let's go to preferences here. You can set all these things yourself. The highest voltage I want is 3.6. I might change that to 3.55. Low voltage at 3 volts per cell. And remember, these are 4P, and they are 55 amps each one, but 4 of them, that makes this 220 amps for the whole system. And so this is how I have it set. Have it set for lithium iron phosphate. Rated capacity is 220 amps, and of course the nominal voltage is 3.2. One board, 16 cells. And here's where you set your temperature. And I think it's very important. You can, from all I understand, that if you try to charge your lithium iron phosphate at 0 degrees centigrade or lower, you're going to damage your batteries or permanently ruin them. So I have it set for 0 degrees centigrade, that the charger, since I have it hooked up to P negative, it will not charge these batteries. The BMS will protect it. I originally thought, because when I first started putting packs together, lithium ion cells, that I didn't need a BMS. I think you're crazy not to have a BMS to protect your huge investment. Now these cells were about $1,600, all of them. They ran about $220 for 8 of them. So you can make a 24-volt system if you put these in series, 8 of them. But I wanted 64 of these to have this is about 11 kilowatt hours altogether, a little over 11 kilowatt hours. I have tested these batteries, and they put out more than 55 amps per cylindrical cell. I was very pleased with these batteries. I have ordered some other prismatic cells at 280. I'm waiting for those to come in, and they'll be added to this, and then I can run it further than 440 watts. I don't want to stress these batteries right now, so that's all I have it set for. But when the other batteries come in, I'm going to plug in at least 1,000 watts going into our house at night, and that'll cover. The sun's out, it'll cover every little bit of almost everything. I won't have to pull anything off the grid. So I'm very, very pleased with this setup that I have here. Very excited about it. This is more exciting than all the solar panels I put up, because I wanted to be able to generate power at night and not use the grid. And I think this will do it for me. Thank you for watching. I appreciate your support. Talk to you later.